How are you, my friends? In this video, I'm presenting 6 old exams questions related to Algebra of Matrices from lecture number 33 of the pre-calculus course. Old exam question number 1, we have the matrices C and D. Find the sum of all entries in the second column of the matrices CD and DC. First, we have to check if we can find CD and DC or not. It depends on the dimensions. So first, check CD. C is 3 by 3 and D, 2 rows here, 2 by 3. So these numbers do not match. That means we cannot find CD. So the product CD is not possible. Now let's see DC. The matrix D is 2 by 3 and the matrix C is 3 by 3. These numbers, they match here, 3 and 3, the same number. Yes, so we can multiply and find DC. So we write here D, all of it, and then we write D. So we take row by column. Remember the multiplication from lecture 33. So minus 1 times 5, 0 times minus 2, 5 times 4. So that's 15 here. Then we take row 1 by column 2 here. Minus 1 times 8, 0 times 0, 5 times 3. So that would be 7. You can continue like this. We see on the next slide. We continue row by column, row by column, row by column until we get 15, 7, 8, minus 5, 12, and 1. What do we need? The sum of all entries in this second column. See, look at the question here. The question, the entries in the second column. So we take the second column. This is the second column here, 7 and 12. So when you add them, you get 19. Question number 2, let's see if this is possible to find W. We have one matrix here, 1, 2, 3, 4. So this is 4 rows, 4 by 1. And we have here addition and subtraction. So we have to simplify inside the bracket first. So what can I do? Multiply this by a scalar here. So this is 8 minus 2. And there's a minus here, subtraction. I can change it to plus, but I have to change all the numbers inside as if I multiply by minus 1. Then I will add 5, 8, minus 2, that will be 11, minus 6, minus 2, and 9, that will be 1. So I have to multiply to find W now. This is 4 by 1, you see 4 by 1, and this one, the result here, 1 row by 2. So these numbers, they match, then I can multiply to find W. So W will be 4 by 2, the dimension. So I take row by column, see I put the details here, row by column, and then row by column, 3 times 1. Another row 2, row by column, until I get 33, 3, minus 11, minus 1, 0, 0, 77, and 7. This is W. Question number 3 is nice. We have 2 parts there. Given a matrix A, 2 by 2. Find the sum of all entries of the matrix 2A squared. This is a little tricky here. When you see A squared, you cannot square each number. That's wrong, remember. So first you have to find A squared, which is A times A. So that's a normal multiplication. So you multiply row, you see this row here? 2 minus 3 by this column, 2, 5. 2 times 2, 4, minus 3 times 5, minus 15. So the number here is minus 11, not only 4. So we continue, multiply row and column until you get A squared. Then this is a scalar here. 2A squared multiply 2 by the whole matrix A squared. Let's find the sum. You find the sum of all the elements, minus 38. Now the second one, we need 2A squared plus A. So we get from part A, 2A squared there. We just add A. This is 2 by 2, and this is 2 by 2. So that will be minus 22 plus 2, that's minus 20. Addition and subtraction, guys. you can add and subtract elements in the same location. But multiplication, you have to multiply row by column. 30 and 5, this is 35, minus 28 and 1, this is minus 27. Find the product if possible here. Let's see, check the dimension and see if we can find the answer. You can check it, please, and then if you are ready, let's go to the solution. Let's see, before multiplying, check the dimension. This one is one row. See, this is one row, 1 by 3. And this is 3 rows here, 3 by 1. Yes, these numbers are the same. So the product is possible, and we can multiply, and the result is 1 by 1. Amazing. So this is one row, one column. So I multiply 4 times 3, and then I will add 2 times minus 3, I will add minus 7 times 5. So this is one number here. See, that's 12 minus 6 minus 35. One number in the matrix, 1 by 1. So the answer is minus 29 as in matrix. Question number 5, little easy. True or false? 3 parts. AB is equal BA? False. These are matrices. If you multiply real numbers, yes, they are correct. 5 times 2 is 2 times 5. But these are matrices. So the first one is false. Unfortunately, the second one is false, and the third one is false. Oh boy. First one is not correct because the product of matrices is not commutative. We have seen that in the lecture 33, example 7. Or you can try any matrix A, take a simple example, 2 by 2. Any A, any B, 2 by 2. Multiply AB, multiply BA. You can see example 7 if you like, or you can try it yourself. A minus B, A plus B is equal A squared minus B squared, not correct. Because A and B are matrices, remember. Now when you multiply these, you will get A squared plus AB minus BA minus B squared. Remember, these two are not the same from part A. So that's false, this is true. This one also, A plus B squared, that's false. The correct one is A squared plus AB plus BA plus B squared. And these are not the same because part A is not commutative. Question number 6, we have matrix A and B. See, A has 1 row, 2 rows. So this is 2 by 4 columns, 2 by 4. We need a matrix X to find it from this equation. 3A plus 5X is equal to 3X plus B. Now after that, we need find the product of all the elements in the second row of this matrix X. So first we find X, then we multiply all the elements, all the entries in the second row. Let's rearrange the equation here. 5x, bring 3x on this side becomes minus 3x, so that will be 2x. On the other side, we have b minus 3a. So 2x will be b, this is b here, minus 6310, 3274, minus 3. That's a scalar now. We have to multiply it with the a. So we can do it directly because we have seen many examples. Minus 3 here, see, you multiply by 2. This is a scalar, so multiply by each entry. So that would be minus 6. When you add minus 6, that will be minus 12. I will do one more. Minus 3 times minus 1, that will be 3. And there is a 3 here, so that will be 6. You can continue like that until you get 2x. Now we need x multiplied by scalar half. Don't say divide, we say multiply by scalar half. So x will be half times this. So it will be minus 6, 3, 7 over 2, minus 15 over 2, minus 3, 1, 2, and minus 4. That is x. Now find the product in the second row. What is the second row here? Minus 3, 1, 2, and minus 4. Now look at the question, please. Find the product of all elements or entries in the second row. This is the second row. Minus 3, 1, 2, and minus 4. So the answer will be 24. Now these are the answers of the 6 questions we just did. For other examples, rules and formulas, if you want to see, please, you can go to the video on pre-calculus course, lecture number 33, Algebra of Matrices. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you for listening.